The next section of this chapter 2 involves the programming languages, which are the Excel and Matlab used in this in the book actually, and in two of these we will be using Matlab in this class. But I would like to show some introduction for Excel as well, so that you can maybe use it because it's easy to use and widely available if you are using a Microsoft operating system. And Excel is the spreadsheet produced by Microsoft. And the spreadsheets are actually special type of mathematical software that allow the user to enter and perform calculations on rows and columns of data. It's basically kind of a table with rows and columns. You type the values, equations, or the statements into the columns. You can make kind of a table, and also you can calculate some stuff in it. And Excel has some built-in numerical capabilities, including equation solving, curve fitting, optimization, operations, mathematical operations, and also it has several visualization tools such as graphs, three-dimensional surface plots, and that serves as a valuable agents for numerical analysis. Also, it has some visual basic capabilities, and we can simply develop our own codes using this as a macro language. So we can create macros like the functions in Matlab or the modular parts. We call them macro in Excel, and we can simply use them to implement numerical calculations. You can see here an example Excel spreadsheet for parachutist problem. For example, we defined the constants here for the parachutist problem, and here we calculate the formulation, Euler formulation behind actually this. There is a formulation, and this shows the results. The Excel shows the results here, but when you click on this array, for example, you can see the formulation behind it at the top of the spreadsheet easily. And with different t values, we obtain v values and analytical v values, and we can simply plot these, as you can see, and this is easy to do in Excel. So we are not going to learn the details of Excel in this course, but if you want to improve yourself, you can start reading chapter 2.4 in your book to further learn about Excel, or you can simply start using it in your Microsoft Office software. Another software defined in the book is Matlab, and we are going to be using Matlab in our course as well. And Matlab is the flagship software for the MathWorks, which is co-founded by the numerical analysis, as you can see here, Clive Moder and John Liddell. So Matlab is called actually the abbreviation of Matrix Laboratory, originally developed as Matrix Laboratory, and it is based on matrices, we can say. So arrays are important in coding, especially for calculation, and Matlab is using this advantage. For example, for the do-and loops, instead of doing all the calculations in a sequential way repeatedly, we can simply type them in a matrix and multiply matrices and obtain all the results at once. So Matlab is using matrices still as the major element, and to the matrix manipulations, Matlab has added also a variety of numerical functions, symbolic computations, and visualization tools, and so that we can use that as a code software easily. And a Matlab code can be directly written to Matlab command window. So we have the Matlab command window at the bottom of the Matlab software window, and you can simply type in all the codes over there. For example, for the parachutist problem, the G, M, CD, and TF values, you can write these down, and then you can write the formulation, Euler formulation, as you can see here, very simple. With these 5 rows, you can simply calculate the velocity. And here the velocity is calculated for TF equals 2. You can simply change this from 2 to 4, 6, 8, and you can have different V values. So this is very simple. And with Matlab command window, we can simply try everything to see the result of it. And just type in, try, and see the result. And we will be using Matlab in this course. And that's why you should read chapter 2.5 in your book to further learn about Matlab. And you can actually take some free Matlab training actually courses from the Matlab website. If you Google, you can easily find from MathWorks website. So for the Matlab command window, if we go back to that, the MATLAB command window doesn't save these codes actually. You can just type them in, get the result. When you close the MATLAB in your computer, these disappear. So there is no way of saving these if you use MATLAB command window. But there is an option to save these, and I will show that in the following slide. So to be able to save the written codes in MATLAB, we will be using the M files. M files actually has an M actually as the extension, and this M file is the generic form of MATLAB functions, basically MATLAB files. Let's say all the functions, all the codes are written in M files and can be saved. Then even if you close MATLAB and open it again, you can simply click on that M file and run the code again. So it's kind of the text file or script of the MATLAB. So for example, for the Parachutist problem, you can simply create an M file and write these values over there. And in the M file, when you run the M file, for example, here we made a change actually. We called the mass as input mass, so it will show in command window as mass. So actually we can write this into M file, save M file, then run M file. When you run M file, it's a separate window than the command window. When you run it, you will see this statement because we actually inputted it as mass kilogram in we wanted MATLAB to show it, and MATLAB shows this, and you type in the mass value here to the command window, and then when you press enter, you will see, let's say you entered 100 as the kilogram, then you will see this result in the command window. So basically M file is a separate window. When you run it, you will see the results or the wanted inputs on the command window. So two windows work together, we can say, for the M files. Let's now show MATLAB coding style. When we write a pseudocode for an algorithm, we can simply convert it to a MATLAB code actually, because they are very similar. So you can see here for if then else, and if then else if cases. If and if is basically if and in MATLAB, and the condition is basically, for example, b is not equal to 0, and true block is the calculation of a mathematical operation. Here R1 is minus c divided by b, for example. This is kind of the example MATLAB code for the root finding problem, if you remember in the previous slides or previous courses. Similarly here, if then else, if else and there are calculations here, and there is a condition. You can see that the condition is here, a is smaller than 0, and b is, this is a computation, this is a computation. If else and statements are here, so it's very straightforward, as you can see. It's similar here, if else and it's very similar, and calculations here in the blocks. For case scenario as well, there are 4 cases, and 4 cases are these. Simply you can just have these, and you can have the test expression as switch a plus v. So you use switch in MATLAB to be able to have a switch between cases. For the do exit pseudocode, from do to end to, we have 2 blocks and if condition. So as we said earlier in the section of do exit, we said that MATLAB will use not do but while in the code actually. So when you see this pseudocode, or when you try to write do and do pseudocode, if you convert it to MATLAB code, you will use while operation. And in the while, we basically have a condition, then a block computation, and finish it with end. And for the count control loop, it's do for and do, and in MATLAB it's just for and end, and it makes for certain counts from 1 to 10, for example, with 2 increments, and calculate this and finishes the code actually. And with these simple cases, you can see we can simply use MATLAB coding from pseudocode. If we know the pseudocode, it's very straightforward to switch to MATLAB code actually. So in this slide, we will use the Parachutist example and we will develop a Matlab code for it. And we already actually developed the pseudocode for the Parachutist example in our previous slides and courses. And we can simply formulate it as an exercise here as an N file in Matlab. So simply on the left hand side you can see the code. This code starts with the inputs and the t values, v values, initial values, and then we have a while loop, which is do for loop actually, do exit loop, sorry. And in here we will calculate dv dt, then we will calculate the next v as the Euler method, as you can see here. Very straightforward. This is not a modular programming for now. This is just a straight specific pseudocode programming for the Parachutist example. But later on we can actually modify this and make it as a modular program, but it's not the current approach now. And we simply calculate the velocity by using this code. You can simply copy and paste this, create an M file, actually open a script in the Matlab script in the window, then copy and paste these and save this as an M file, then run this in the Matlab and you can obtain the results. And for different masses, input, you can obtain different velocity values. For example, if you type 100 here, you will calculate the velocity as shown. And in this slide, we are showing how to create the Matlab code as a modular programming. Instead of having a Matlab code specific to the Parachutist problem, we will create a modular program, specifically a function for Euler method, and we will use this for the Parachutist problem. So remember the pseudocode for Euler method. This was the pseudocode, and we simply converted this to a Matlab code. And in Matlab, you can simply actually write this down or copy these and paste to the Matlab script and save it as Euler.m. Then we also need to calculate this slope function dy, and for that we had also a pseudocode for the Parachutist problem. Simply write this like here as a different function, dy.m. Then you can simply use this function to get the result. So what we will do now, we have two functions, two M files, and in the command window we will type in the initial inputs, then we will call this function Euler function as shown here. Then what it does is the Euler will use these in these inputs and calculate this y value. First it will use this function, call this function, calculate dy dt, then use it here, then use it here, calculate y value, then it will show this y value as the velocity, as the answer, as you can see here in the command window. So this is the straightforward implementation of a modular programming and as an example for the Euler method, and you can use this for Parachutist problem as well as in different problems in the future. At the end of section 2, we will also mention about other languages and libraries. So we mentioned about Excel and specifically Matlab because we will be using Matlab in this class. But there are other languages such as Python, Fortran, C++, Matcat, etc. These can be also used in numerical methods to be able to develop the certain pseudocodes, algorithms, the codes for the algorithms and pseudocodes for the numerical methods. And in this class, our purpose is, or approach is, to provide well-structured procedures written as pseudocodes. So we will be trying to use well-structured codes and develop modules, especially to be able to use to solve the problems with the numerical methods. And then we will have some libraries. So actually, library means that the codes, the collection of the codes that we write in a language. Language is the Matlab actually in this class. And we will have collection of algorithms. Then these will turn into a numerical library. And we can access these to perform specific numerical tasks in a range of software tools and programming languages. So this will, for us, it will be easy to solve numerical methods after this class by using Matlab. Or also, because we will have the pseudocodes or generic algorithms, we can if we want, we can write our own codes for different languages as well. But for this class, our main programming software for demonstration will be Matlab. And with this, we completed section 2. And if you want to have further information, you can read chapter 2 in your book from sections 21 to 27 in pages 28 to 49. And thank you very much for listening. See you in the other class.